Hey everyone, I'm Gloriane Delgadillo and I'm a senior chemical engineer.
Hey everyone, I'm Bradley Miller and I'm a senior chemical engineer.
Hey everyone, I'm Albuloushi and I'm also a senior chemical engineer. Our project was designing a 3D printed elbow brace.
Motivation. Elbow injuries and nerve damage in the arm are very common throughout the worldwide population. Most common treatments are surgery, orthotic devices like braces, and other physiotherapeutic procedures. Our motivation for this project is to utilize 3D printing to make an elbow brace that ensures cost effectiveness, affordability, and ability to customize for every individual.
To begin designing, the first step we took was looking at modern elbow braces that are used, such as the top right image. This example of an elbow brace is a typical design that can be recommended by a doctor. However, they can lack comfort and are pricey. This specific elbow brace can be found on Amazon for $97, and some can even go for more. We also looked at 3D printed designs of braces, such as this hand brace. The 3D design allowed for breathability and was made up of two identical parts, which can be easy to put on. This research inspired us to design an elbow brace that is comfortable and easy to put on. To model our design, we used the SolidWorks software, which allowed us to 3D design our desired product. We began by creating two circles and used the loft feature that connects the circles as tubes. Once that was done, we made it hollow in the middle and made an inner diameter of 0.25 inches thick for more stability. Inspired by the design we previously mentioned, we decided to cut our brace in half and make it into two pieces. Once that was done, we wanted to include holes in the brace to allow for air to pass through the arm, to increase comfort. The final step was to create rectangular holes at each end to allow the Velcro to hold pieces together around the arm. The last image shows our final design on SolidWorks. Here's a demonstration of 3D printing our design.
So for our experimental results, the first prototype design and the second prototype design were both made out of PLA polymer, and they were both printed using a USF 3D printer. The prototype can be custom fit with measurements of an individual's elbow, and this design specifically went from a digital design and to the first prototype and then to the second. For the initial first prototype, it did not come out as correct as we wanted to. We actually used two different printers and they gave us non-symmetric sides, so they wouldn't fit together properly. So this issue was addressed in our second prototype. We were able to print off the same printer twice to ensure that they were symmetric and could fit together. The design, it was a bit small for human use to be able to prototype properly, but this is just because of the lack of the printer size. We think improvements could be made on the angles of the design and inner support could be added. So here are both the prototypes that we created. So for the first prototype, we have two sides that are not fully symmetric, but it does show the breathability, and it is our prototype model. It did not have the full size that the printer could make. It was our first initial prototype, and the second prototype we used from the same 3D printer, able to make a symmetric piece, two symmetric pieces, and it was actually to the maximum allowable limit of that 3D printer, and still we need to find a better, bigger 3D printer. So this is a final design demonstration video. So for future work, we believe that our design could be amended to increase the overall size of the brace. This will be done by using a bigger 3D printer and also adjusting the angle of the brace to better fit an individual. This will have to be done with every individual to be able to custom fit them. And also padding can be added on the inside to improve comfort. So here are our references for our images of the brace. Thank you very much.